Hello everyone, welcome to Academic Coordinates. In this video we are tackling geometric sequences, right? So in this type of sequence, or in this type of a sequence, the following term, right, except for the first term, the following term is obtained by multiplying the previous term by a constant value. We call this constant value R, which is a constant ratio, right? So let's do this. So now the first term is going to be A, right? In order for you to obtain T2, you are going to multiply the first term by R, right? So this is AR to the 1. Yeah? And then T3, you are going to multiply the previous term, which is A times R. This is T2. You're going to multiply that by a constant value, and then you're going to have AR squared. And then let's go to the fourth term. The fourth term is going to be A times R times R. So this here is the third term. You're going to multiply the third term by R, and then your answer is going to be AR to the third. Let's do also the fifth term. The fifth term is going to be A times R times R times R. This is the fourth term. In order for you to get the fifth, you're going to multiply the fourth term by a constant value R. Then you're going to have AR to the fourth. So now I want you to observe what is going on here. What will be the Tn of a geometric sequence? So you've got A, right? Let's check here. The exponent of R. I put it to you guys that if you say R to the 0, R to the 0 is going to be 1, right? So this is 1 here. This exponent is 1 minus 1. This is 2 here. This exponent is 2 minus 1, which is 1. This is 3. Here you've got 3 minus 1, which is 2. This is 4. Here you've got 4 minus 1, which is 3. This is 5. Here you've got 5 minus 1, which is 4. This is n. And then on the exponent of R, you're going to have n minus 1. So this, guys, is the general term. Just to recap here, a sequence in which the following term is obtained by multiplying the previous term by a constant value R, as we have done here. And then from there we found the general term, right? And then now Tn is obviously the general term, or the nth term, right? The nth term. And then A is the first term. The first term. R is the constant ratio, right? And then N, still the same, the position of the term. Okay, so basically, how can you confirm really that this is a geometric sequence? You confirm using R. You check if T2 divided by T1 is equals to T3 divided by T3 divided by T2. Is this equals to T4 over T3? I trust you guys can see what is going on here. So in other words, is this equals to Tn plus 1 divided by Tn? You can confirm using this whether you are dealing with a geometric sequence, right? So I want us to do a bit of an example here. So we've got 4, 8, 16 right here, and this continues. So basically, is this an arithmetic sequence? And if it is, let's determine the general term. So now let's check for R. R is going to be T2 over T1. Is that the same as T3 over T2? So T2 over T1 is going to equals to 8 all over 4. So what is that? That is 2. What about T3 over T2? That is 16 over 8. That is also 2. So now R is equals to 2. A is equals to 4. So what is your Tn? Tn is equals to A times R to the n minus 1. So Tn is equals to, this is 4 for A, right? And then R is going to be 2 to the n minus 1, right? So that is your general term. So it is basically Tn is equals to 4 times 2 to the n minus 1. And also, I mean, you can simplify this further if you want. This can be Tn is equals to 2 squared times 2 to the n minus 1. And then you've got the same basis. So it's going to be 2, according to the laws of exponents now, 2 plus n minus 1. So Tn is equals to 2 to the 2 minus 1. That's going to be plus 1. So it's going to be n plus 1. You guys see that? Let's say minus 3x minus 3x squared. And then I know this is in terms of x's, but we use the same basics that we've been exposed to, right? And we are told that this is a geometric sequence. So R is equals to T2 over T1, right? Then T2 over T1 is going to be minus 3x divided by minus 3. This equals to x. I mean, for fun's sake, let's check if that equals to T3 over T2. That is minus 3x squared divided by minus 3x. You still get x over there, you know? And how do you do this really? A negative divided by a negative is a positive. 3 divided by 3 is going to be 1. So you'll be left with x to the 2 minus 1, which is that. Okay, so this now is your R. And then your A is minus 3. So Tn is equals to A times R to the n minus 1. So Tn is equals to A is minus 3. Then R is x to the n minus 1. There you guys have it. So this is a geometric sequence. 1 over 2, negative 1, and 2. So you are told that it's a geometric sequence. Then your A obviously is a half. You know, what about your R? R is T2 over T1. It's going to be negative 1 divided by 1 over 2. This is what? Negative 1 times 2 over 1. So I guess you guys can use that. You can use your calculator if you want. So it's going to be here. It's going to be minus 2. So that is your R. Your Tn is equals to A. What is your A? A is 1 over 2. And then your R is minus 2 to the n minus 1. This can be simplified further. Maybe let me show you how you can do that. I don't think you'll be forced to do that, but anyway. A half is the same as 2 to the negative 1, right? Minus 2 to the n minus 1. So you can do this minus 2 to the negative 1 times 2 to the n minus 1 over here. Then this is minus 2 to the negative 1 plus n minus 1. This is 2 to the n minus 2, right? Okay, let's consider, let's say you are told that this is a geometric sequence. You are told that 9 over here, P and 36, you are told that this is a geometric sequence, and then you are told to determine P. So now, if this is a geometric sequence, it means that R, which is T2 over T1, should also equals to what? T3 over T2, you know? So now, what is T2? T2 is P all over what? All over T1, which is 9, This should equals to T3 is 36 over P. So if you cross multiply, you're going to have P squared is equals to 36 multiplied by 9, right? P squared is equals to 324. So now, what is your P? P will be plus or minus square root of 324 plus or minus 18, right? Plus or minus 18. That would what your P would correspond to, you know. Okay, so let's say you are given 3x 48, and then you are told to determine x in this geometric sequence such that x is greater than 0. So same principle, you know. So T2 over T1, T2 is x, T1 is 3. This should equals to 48 all over x, right? So if you cross multiply, it's going to be x squared is equals to 48 times 3. That equals to 144, right? And then if you take the square root of x, you're going to get that this equals to 12, right? Okay, let me just do this and not having you ask me questions. So this is x is equals to plus or minus 12, but now you're told that x should be positive, hence x is equals to 12, right? So this is geometric sequences in a nutshell. So basically what we've covered here is that a geometric sequence is a sequence such that the following term, you get it by multiplying the previous term by a constant value, which we did here. And then we found the general term of a geometric sequence, and then we expressed all of those terms. The test whether something is geometric or not is actually the R. R is T2 over T1. It's a constant ratio, you know. So this should be the same. So take note, you might not be given, let's say, T1 or T2, but let's say you've got T27 and T28. So your R will equals to what? T28 over T27. You see? So just take note that it's the term that are following each other, and then we did a multiple examples here. So do stay blessed, guys, and enjoy the rest of your day.